Hey, good morning, ladies and gentlemen, boys and girls. Guys, welcome to another episode on the Incredible Academics YouTube channel. Guys, today is the 29th of January 2024. Okay, so there's a problem that I want us to look into. So here's a diagram that we've been given, and here we need to find the area, right, of only the shaded triangle, right, in terms of x, alpha, beta, phi, and theta. Okay, so let's go right ahead and do that, and we're gonna need some luck, to actually be able to crack this one. So that's question 6. So the shaded triangle, that's the one that we're supposed to find its area. So let's go for it. Now I've already drawn a rough sketch of the problem, right? Yes. So now really the thing that you want to do is you want to use what we call the link method. And I remember last year one of my learners actually asked me if I know this method called the link method, and I was like, no, I don't. Tell me about it. All right. And she explained, and as when I thought about it, she did explain, but I didn't quite get it. But as when she kept on explaining, I kind of like started to understand, just from the name of the method, I started to sort of like get the idea of what the method is all about. So the link method is about focusing on other triangles and then using that information from the other triangles to then link to the main triangle. And if you check the main triangle, the triangle of focus right now is this triangle, EBD. Why am I saying this? Because it's a triangle that we need to find its area. And you guys know, to find the area of any triangle that is not a right angle triangle, we're going to use the area rule. And with the area rule, we need an angle in between. And really you want to operate with information that's already given. You can see that the angle theta is already given. All we need to do is to find ED and BD, right? Because remember, you need two sides that are adjacent and the middle angle, right? The angle at which the two sides meet. Do you get what I mean? So I already know exactly what needs to be done, because like this angle is giving me a clue. But I also, from the link method, I know that I need to work in this triangle and also in that triangle in order for me to be able to find the sides that are needed, and then I use that information to then find the area of that particular triangle. So now where do we start? I mean, this triangle is the easiest to work in because of this, right? We don't even need to use any sine rule or cosine rule to find the length of the side, right? We just need to use trig, okay, because of this right angle here. So we're just going to say, okay, fine, the angle that we're looking for is actually BD, right? So we're just going to say, okay, we know that BD is the hypotenuse, isn't it? So x over BD, which is adjacent to the hypotenuse, that's going to give us the cosine of B, right? The cosine of beta. So we now know that, okay, fine, BD, which is the hypotenuse of this triangle, is just going to simply be x over the cosine of beta. Okay, so minus one problem. We already got what? We already got BD, and what we need now is the length of BE, right? BE, not BE but ED, right? We need the length of ED. So if we can find the length of ED, I think that would be great. But if we check, according to the length method, this triangle can only give us BE. Do you understand? And this is an exterior angle of a triangle, right? And we know that this angle here, that's missing. This angle here, that angle, if we were to add it with theta, it's going to give us phi. Okay, so meaning that that angle over there is actually phi minus theta. So this is phi minus theta, the angle at the corner there. So meaning that we need to calculate the area relative to this angle over here. Why? Because we can only find BD and EB. There's no way we can find ED, you know, using this triangle, because remember we already used this triangle. So now we need to use that triangle to find the other side, and then once we've got the two sides, then we can operate in that triangle. So now let's find EB or BE. So BE, right? BE over the sine of alpha. So BE over the sine of alpha must be equal to what? X over the sine of phi. So this is a sine rule. X over the sine of phi. So now BE is simply X sine of phi over the sine, sine of alpha over the sine of phi. And that's that. We've got the two lengths now. We've got the two lengths which belong to the triangle BED, right? BED. So with the two lengths BE and BD, then we can find the area. Okay, so because the area is simply going to be given by area, it's 1 over 2, right? 1 over 2 times what? Times BE times BD, okay, times the sine of the included angle, right? The sine of the included angle, which we shall call angle B, right? We shall call angle B. What am I talking about? 1 over 2 BE times BD times the sine of the included angle. Okay, so that's our area rule. So 1 over 2 times, but what is BE? We've just calculated our BE. That's X sine of alpha over sine of theta. X sine, right, X sine of alpha, X sine of alpha over sine of phi, okay, times, what is BD? Okay, we go up there, there's our BD, X cosine of B, right, X cosine of beta, cosine of beta, times the sine times the sine of the angle between the two sides, which is phi minus theta, right? Phi minus theta. Okay, and the area is done. Okay, the area is done. So this is just going to become x squared. Okay, so it's going to become x squared, the sine of alpha, the sine of phi minus theta, divided by 2 sine phi cosine of beta. Okay, and that's our area, you guys. right, in terms of the exact parameters that they requested, right? It's in terms of x, alpha, beta, phi, and theta. Okay, right. So now let's hop on to a slightly, this is like literally one of the problems that learners struggle with when there's no numbers and all that. Okay, problems that involve a lot of algebra, but hey, it takes practice. Once you've practiced enough, you'll definitely be able to get the hang of it. So what I'm gonna do now is that I'm gonna move on to a slightly more complicated problem. Okay, there's the thing that we're given. We've got that diagram over there, and we need to show that PQ is given by that. Also TR is given by that. Yeah, I don't know how we're gonna do it, but hey, we just gotta try. Hey, we just gotta try. So let's look at PQ. You see, PQ is within this triangle, right? PQ is within this triangle. So according to the link method, we need to use other triangles to sort of like get information that's going to feed into our triangle of interest. Okay, for instance, that angle is not given. Can we use other triangles to find the size of that angle in terms of whatever parameters that we have? Okay, so like it's just one of those things that you need to consider when solving this type of problems. So PQ, let me see. No, it's PT, right? It's PT. So because I was still wondering what's going on. So PT is within that triangle there. So meaning that now we need to use this triangle to find information that we can use in that triangle. All right? So that's your PT. Now, how do we start? How do we start? PT. Well, first of all, we need to find the angle here. Right? Yeah. So we need to make sure that the triangle whereby PT is found, there's as much information as possible. Okay, so we need to find the lengths of the sides, for instance PR and TR, so that we then use that to find the missing side, which is PT. So what I'm going to do now is I'm going to find R1. Okay, angle R1 is definitely equal to 180 degrees minus what? Minus alpha minus beta. Okay, which is simply 180 degrees minus theta plus beta. So that's our R1. All right, and also remember the two lines are parallel. Okay, the two lines are parallel, so we can use the fact that alternating angles, parallel lines have got alternating angles. So angle T1 is what? Angle T1 is basically equal to what? I hope we said beta. All right, angle T1 is equal to beta. And what else can we find? So now we know that angle over there, because this is beta, that entire angle over there is simply theta plus beta. Okay, so I'd suggest that we find the length of PR. Okay, can you see where PR is? PR, because PR belongs to both the two triangles. So once you've got the length of PR in here, it automatically belongs to the length of PR in there. Okay, and yeah, let's do that. Let's find our PR. So this triangle here, it's easy to work with because there's what? A 90 degrees angle. So we're simply going to say, okay, so x over what? Over PR, that's the sine of what? This angle. I hope you agree. So opposite over hypotenuse, that's sine of this angle. So the sine of alpha is equal to x over PR. Therefore, PR becomes what? PR simply becomes x over the sine of alpha. Okay, so we've got our PR now. So now that we've got PR, I think we are ready to find PT, right? PT. We're ready to find PT. Why? Because we've got the size of this angle over there, and we also have the size of that angle over there, which is opposite our PR. Do you understand? So we can use sine rule to then find PT. Okay, so PT, right? PT over angle R, the sine of angle R must be equal to what? PR over the sine of we'll just call it angle T. All right, so PT over the sine of this angle here, which we have agreed that it's 180 degrees minus alpha minus beta. Right, this angle over here, and this one, it's simply theta plus beta. Okay, so yeah, so also PR over that. So let's continue. Now we know that, well, PT is unknown, that's fine. The sine of R, our angle R, remember we said it's 180 degrees minus theta plus beta. So 180 degrees minus theta plus beta. All right, and that's equal to PR. And remember, we've already found PR. There's a PR. PR over sine of T. So PR is just x over the sine of alpha. And now the sine of angle T is simply the sum of alpha, beta and theta. So the sine of theta plus beta. Okay, so now we're ready to simplify. Okay, let's break it down. So the sine of 180 minus any angle is simply going to be the sine of what? Theta plus beta. Remember, sine is positive in the second quadrant, so 180 minus a particular angle that's in the second quadrant. So this is equal to what? So it's x over sine of theta times divided by this, so it's the same as x over sine alpha sine theta plus beta. Okay, sine theta plus beta. So then we make our PT the subject of the formula. PT then becomes, we'll multiply by the sine of alpha plus beta on both sides of the equation. X sine of alpha plus beta over the sine of alpha and then the sine of theta plus beta. So now let's check if this is the same as what we are given over there. So x sine of alpha plus beta, sine of alpha, sine of theta plus beta. So it's exactly the same. All right, exactly the same. So now we need to find the other side, which is TR. And I can tell you what, to find TR, we're probably going to have to use the very same PT. Okay, so let's check where TR is located. TR is within the very same triangle that we're dealing with. So we know that, so we've already calculated what PR, remember, PR has been calculated. So PR is just x over the sine of alpha, and PT is what we've just found, x sine of alpha plus beta divided by sine of alpha, and then the sine of what, theta plus beta, right? So we've got the two what we call lengths, and now we need to find TR. Okay, so we need to find TR using the information that's there. And what I can tell you is that we what can we use? Right, so we've got two lengths. Yeah, I mean, we need to find that angle over there, right? If we can find that angle over there, then we're good to go, because we can then use sine rule, right? Or even cosine rule, although cosine rule is kind of complicated, to then find the length of TR. So how can you find the length of P1? So we know that angle P1 plus angle T plus angle R, that's equal to 180 degrees. Okay, so so angle P1, because remember this is just a triangle, so angle P1 plus angle T plus angle R1, that's just 180 degrees. Okay, so but we already got angle T, which is just theta plus beta. Also angle R, it's just 180 degrees minus alpha minus beta. 180 degrees minus so alpha plus beta, which is equals to 180 degrees, right? 180 degrees. So this and that, they're going to cancel. Okay, and then beta and beta, they're going to cancel. So basically we've got angle P1, all right, angle P1 plus theta. Remember we said the beta and the beta, they're going to cancel, so minus alpha is equal to 0. So angle P1 becomes equal to alpha minus theta. Okay, let's go and plug it in. So this is alpha minus theta. Okay, alpha minus theta, that's angle P1. So I mean, if we've got that, we can simply use our sine rule. Okay, so RT over the sine of that must be equal to x over, must be equal to PR over the sine of that angle. Okay, so there's not enough space here. but I'm just gonna write it down for you guys. So RT over the sine of what? Of P1, right, must be equal to PR over the sine of what? PR, well, yeah, over the sine of T, angle T, okay? And then we do the substitution. RT, the sine of P1 is what? P1 is just alpha minus theta. And PR, it's just x over the sine of what? Alpha. Divided by the sine of T, and T is just theta plus beta. So the sine of theta plus beta. Okay. Then we make everything the same with the formula. Alright. So you realize that on the right hand side, what we actually have is, it's just x over sine of alpha divided by the sine of that. So the answer is going to be x over sine of alpha, the sine of theta plus beta, right? That's the right hand side. So then we need to multiply by what? On the left hand side, we multiply both sides of the equation by the denominator, which is the sine of theta minus alpha. Alpha minus theta. So this is just going to become sine alpha minus theta. And so this is our RT. And if you check, this should be the same as that. X sine of alpha minus theta over the sine of alpha sine of theta plus beta. So we have answered the question, ladies and gentlemen. Congratulations to us. Finally, we got to the end, and hopefully you guys have been following. And if not, put something in the comment section. Let's see where we lost you. But otherwise, on my side, it's been a fruitful lesson, and looking forward to dropping more videos. Don't forget to tell your friends and family that are doing grade 12 mathematics to visit the channel. So this is literally problems from grade 11, right? But I know they're gonna come in handy for grade 12 people, because in fact in grade 12 we're doing what we call Trig 3D, right? So this is just 2D. So it's just a build up just before we get into Trig 3D. All right. So ladies and gentlemen, we've come to the end of the episode, and peace out.